Welcome back. Today I will cover the module number 11, which is Switch Security Configuration of Cisco Switching, Routing and Wireless Essentials lecture series. I would recommend that you also watch the lectures from Cisco Introduction to Networks before you dive into this course. I will leave links to both lecture series in the description. In our previous lecture, which is the module number 10, we briefly went over some LAN security vulnerabilities. In this lecture, we will learn how we can configure switch security to mitigate MAC address table attacks, VLAN attacks, DHCP attacks, ARP attacks, and STP attacks. Please note, this lecture is a little bit lab heavy as opposed to the previous lecture, but we will cover the important theory concepts today so you can go over the labs later and you will be well prepared to do those labs. If you would like to learn about what these attacks are, such as if you want to know additional information about VLAN attacks, I would recommend that you watch my previous lecture on module 10 that also go over all of these attacks briefly. So the objective today is to learn how we can configure switch security to mitigate such attacks. Implement port security. Secure unused ports. Layer 2 attacks are some of the easiest for hackers to deploy, but these threats can also be mitigated with some common layer 2 solutions. All switch ports, in other words interfaces, should be secured before the switch is deployed for production use. How a port is secured depending on its function, but depending on the use or the function of that port, you may be able to secure port using different methodologies. A simple method that many administrators use to help secure the network from unauthorized access is to disable all unused ports on a switch. In Cisco devices, you can do that by entering the shutdown command on each unused port. If a port must be reactivated a later time, you can reactivate it by running the no shutdown command on that port. To configure a range of ports, use the interface range command. So in lab demonstration, I will show you this. What you can do is you can go int range or interface range, and you can give the range. So for example, FA01 and then space, and you can have FA010. So that's FA01 to 010 will be impacted by whatever you're going to do underneath that configuration. And then you can issue no shutdown command for that range. So what's going to happen is FA01 to FA010 will be now shut down. And this type of range configurations are useful for many other configuration applications. But so remember that the range command does exist. And again, I will go through them in a lab demonstration. Mitigate MAC address table attacks. The simplest and most effective method to prevent MAC address table overflow attack is to enable port security. So the port security limits the number of valid MAC addresses allowed on a port. It allows an administrator to manually configure MAC addresses for a port or to permit the switch to dynamically learn a limited number of MAC addresses. When a port configured with port security receives a frame, the source MAC address of the frame is compared to the list of secure source MAC addresses that were manually configured or dynamically learned on the port. In other words, a threat actor with a MAC address, whatever the MAC address they have, cannot just simply plug into your network and get a connection if the port security is implemented and that MAC address is blocked. So by limiting the number of permitted MAC addresses on a port to 1, port security can be used to control unauthorized access to the network. So this is a really good option, especially if you have a switch that connects only, let's say, servers. So typically those server NICs, the network interface cards, won't change. So you will have that constant static MAC address. So there's no need for those switch ports that is facing those servers and those network devices to actually even learn the MAC address. You can actually, as a system administrator, just give the switch those MAC addresses, and only those MAC addresses have access to those ports. So that's an example of a way that you can prevent unauthorized access. So how do you enable port security? Port security is enabled with the command switch port-security in the interface configuration. So if you go to interface, whatever the interface you want to pick, in this example they are picking the interface F01, by issuing the port security command, so switch port security, what's going to happen is that will enable the port security. Notice in this example the switch port-security command was rejected. You see that command was rejected right here. This is because the port security can only be configured on manually configured access ports or manually configured trunk ports. So by default, the layer 2 switch ports are set to dynamic auto, which is the trunking on. And therefore, in this example, the port is configured with the switch port mode access interface configuration command. So the trunk port security in this example that we need to use is beyond the scope of this course. We will learn about the trunk port security in my next course. For in this lecture series, you don't need to know about trunk port security, but you should know that the switch port security command exists, and it will be rejected if the port is set to learn the information dynamically, if it is set to dynamic auto. So those are the key information you should know for this class, and we will learn about the trunk port security in our next class. So the show port security interface command to display the current port security settings for whatever the port that you're looking at. In this example, we are looking at the port associated with interface F01. So we're going to enter show port security interface, or INT F01, and that will display the information about the port security associated with that port. In here it shows that the port security is enabled and the violation mode is in shutdown, and we have the maximum number of MAC addresses allowed in this port set to just 1. So you notice how the port security is enabled right here, and the MAC address is set to 1. So if a device is connected to the port, the switch will automatically add the device MAC address as a secure MAC address. So in this example, you see there are no devices connected to this port right now. So when a device is connected, that would be the only MAC address this port gonna learn, and no other device can connect afterwards because of the port security is enabled. So please note, if an active port is configured with the switch port security command and more than one device is connected to that port, the port will transition to the error disabled state. Because remember, we have the port security enabled here, and as a result, the device will not accept any other MAC addresses. So if another device get connected, it will go into the error disabled state, and therefore the system administrator or network administrator has manually now have to enable back on. After port security is enabled, other port security specifics can be configured. So after port security has been set, you can set up other options associated with that port security. So one of the nice thing about Cisco software, Cisco iOS, is that it has this question mark or help command. So what you can do, actually, you can enter whatever the command you are looking at, you can put a question mark in front of it, and that will give you the options available. So in here, the options showing the aging, if that means port security aging command, it gives you MAC address information, set up the maximum MAC addresses allowed, and the violation, like what kind of violation modes that we're going to use. So all of these options, if you are not sure in Cisco iOS at any point, not just port security, you can always use this question mark command. Again, I will go through them in a lab demonstration, but for now I would just know that those exist. So how do you limit and the MAC addresses that been learned through the these port security configurations? So to set the maximum number of MAC addresses allowed on a port, you can use the switch port security maximum command. So it's a switch port security maximum command with the value, whatever the value the number that you want to set. So by default, the port security value is set to 1. The maximum number of secure MAC addresses that can be configured depend on the switch and the iOS version. So depending on the type of switch that you have and the iOS version which is running on your Cisco device, the maximum may depend on that. So in this example, the maximum is 8,192. That is way more than you need anyway in most scenarios. And if you are not sure which Cisco iOS version you are running and what kind of Cisco switch capabilities you have, you can run again that help command. So you can do switch port ports dash security, and then you can put the question mark to see what are the options. In this case, we are using the option maximum, and you can put another question mark at the end here to see how many what are the values you are allowed to enter in here. So in here it shows that this switch have the capability of supporting 1 all the way to 8,192, and so you can set up whatever the may you want. You can also check this on other devices that is running Cisco iOS. It doesn't necessarily have to have a switch. It had to be a switch. It could be any Cisco device that is running the Cisco iOS versions that support port security should be able to take this command and let you know how many ports are available. So what is the maximum value that you can enter here. So what you need to get out of this is that if you want to set this to, let's say, 10 or 20, what you do actually switch port dash security maximum, and you're going to enter 20 or 10 or whatever that numeric value, and that will give you the option for the limit of MAC addresses that port will learn as you set up the port security. The switch port can be configured to learn about MAC addresses on a secure port in one of the 3 ways. You can manually configure it, dynamically learn it, or dynamically learn with a sticky. So manual configuration is basically the administrator manually configure a static MAC address or addresses by using the following command for each secure MAC address on the port. So basically what's going to happen is you're going to go into the interface. So that's why it's config if right now. So once you're in the configuration mode for that interface, you're going to run a switch port dash security MAC address, and then you give the MAC address, and you can keep entering MAC addresses manually. And this is maybe a good option, especially if you are just configuring a switch that is facing like couple of servers, for example. So the MAC address won't change, and you know exactly which devices are connecting to that switch port, and you can just simply enter those MAC addresses to that switch port and done with it. So basically manually configuring specific MAC address or MAC addresses by the system administrator. The next option is the dynamically learned. So when the switch port is set to switch port dash security. So you have entered this command. The current source MAC for the device connected to the port is automatically secured, but is not added to the running configuration. So if the switch power down and power back up, if it power cycles, for example, it's gonna relearn dynamically that MAC address, whatever the MAC address of the device that is connected to that port, because you have set the switch port security to dynamically learn by running the switch port dash security command, right? So if the switch is rebooted, as I mentioned, the port will have to relearn that MAC address device. But once that MAC address is learned, if the MAC address limit is set to 1, for example, it will not learn any other until there is another reboot or something like that. If another device is connected, it won't have access unless the switch port has set in a way, as we learned in the previous slide, so that it can learn more than one MAC address. The third option is the dynamically learn sticky option. So the administrator can enable the switch to dynamically learn the MAC address and stick them to the running configuration by using the following command. So that command would be, you go into the interface configuration. So that's why it's config here, and you're going to enter switch port, and you're going to enter the command port-security and MAC-address, and then you're going to enter the sticky command. So this is switch port-security, MAC-address, and sticky, and it's going to be, stick them to the running configuration. Saving the running configuration will commit the dynamically learned MAC addresses or MAC address to the NVRAM. So what that means is basically, once you have dynamically learned MAC address, and if you enter switch port-security, MAC-address sticky command, it's gonna save whether you have one MAC address or a couple of MAC address. If you have multiple MAC address configured on the switch port, and it will save to the NVRAM. And now if the switch get rebooted, or if power cycled, it will not go ahead and run the dynamic learning process again. Instead, it will still use the MAC address that it has, or addresses that it has learned from the previous dynamically learned MAC address process. This is something that I commonly use because that will make it easier for us. So you don't need to manually enter the MAC address by running switch port security MAC address and the exact MAC address of the device that is connected to that port. So you basically run the dynamic one, and then you're going to run the switch port security MAC address sticky, and as soon as it's learned, and it gets saved to the NVRAM, and now you don't have to worry about anything, and it's any configuration errors, for example. And also this will make sure when the switch rebooted, that dynamically learned MAC address will still be available on the system, so it doesn't have to relearn it. The example demonstrates a complete port security configuration for fast Ethernet 01. So if you look at the right hand side, how it how they look at that information, look up that information is going into the interface by going int fa01, or just enter interface fa01 and running these commands will get you this display. At the end, you run the show port-security interface f01, that will show you the summary of the information. So the administrator specify a maximum of 4 MAC addresses. We know that because it has a maximum MAC address here shown as 4. And manually configure one secure MAC address. You have a manually configure one secure MAC address. That's right here, secure configure MAC address. And then configures the port to dynamically learn additional secure MAC addresses up to 4 secure MAC address maximum. So you have dynamically learning maximum of 4. And as I mentioned, how we know this information is by running the show port security interface and show port security address command, so that you can verify that information. So right here, show port security interface f01, show port security address, and that will show you that information. So in here, we are looking at the specific interface related information. In here, we are looking at all the interfaces that have the security configured. In this case, we only have one, and it is FA01, and it is displayed here because we ran the show port security address. And if you have multiple ports configured with the port security, this table will display those information here as well. Again, I will show you this on a real demonstration, but for now, just know that these do exist. Port security aging. So the port security aging can be used to set the aging time for static and dynamic secure addresses on a port and 2 types of aging are supported per port. So the aging commands can be used to make sure that the static and dynamic addresses on a port has some the time limits. So the 2 options are the absolute and inactivity. Absolute, what it's going to do, the secure address on the port are deleted after the specified aging time. So when the aging time has expired, it's going to delete whatever the learn addresses from that secure port. Inactivity method, what's going to happen is the secure addresses on the port are deleted if they are inactive for a very specific time. So if you give a specific time saying, hey, if we don't hear back from this device for a certain specified time, it will gonna get deleted from that the port security information. So it got that device MAC address information gonna get removed. Use agent to remove secure MAC addresses on a secure port without manually deleting the existing secure MAC addresses. So the whole purpose of this aging commands is to use them to remove secure MAC addresses on a secure port without you need to be manually going into the switches and changing the configurations. So the aging of statically configured secure addresses can be enabled or disable on a per port basis. So you can use the switch port -security aging command to enable or disable static aging for these ports, or to set the aging time or type. So in here, the Cisco has provided us that command with the options associated with it. So these options are like switch port, then you're going to go port-security, then you're going to go aging, and you can set it as static and or time. And after the time command, you can enter whatever the time you're going to give. And you can enter the type, whether it's going to be absolute type. So we're going to use the absolute type, or we're going to use the inactivity type. So one of the example would be switch port-security aging static time, let's say 50, and then type I can put inactivity. So this is a way of describing the command to a student or to someone else, and with the command option. So that's what it's showing here. If you're reading Cisco manuals, or if you have ever read Cisco manuals, this is how most of the Cisco manual commands will be listed. So it gives you the options that the user enter right here, and it'll give you the options that are available for user that you can pick, either static or time, for example, absolute or inactivity, for example. So these are the only 2 options you can do for aging, static or time. So if you put static, there are not going to be any other option you can enter. But if you enter time, you have the option to enter whatever the time you can you want to set. So if you enter after type, you have absolute or inactivity. These are the 2 options you can pick. Again, if you don't remember some of these commands, you have that help question mark option that you can use on all the Cisco switches, right? Remember that all as well as the Cisco routers as well too. So in this example shows an administrator configuring the aging type to 10 minutes of inactivity. And then we see that the show port-security command is used to confirm that change. So in here we have the switch 1, and the administrator go to the interface FA01, and they issue the command switch port-security aging time from the previous slide that we learned, and they're going to set to 10. In here, 10 represent 10 minutes because that's how the Cisco IOS work. And so basically the system administrator is saying that we are setting the port security reset to timer to 10 minutes, and then it has the administrator has set the switch port security aging type to inactivity. So after 10 minutes of inactivity, it's gonna erase that information, then reset that information, right? So that's what it's saying here. So if you go back to the previous slide, see we have the option of absolute or inactivity, and we have static or time. So this is the command they are using. So they are using switch port security aging, and they are giving 10 minutes on time. So switch port security aging time 10 minutes, and they're going to set the type to inactivity. So that's what happening here. So you're going to go switch port security aging type inactivity. And now after doing that, if you run the show port-security interface FA01, which is this one, you can see that the port status is set to the secure-shutdown and the violation mode under restrict, and you have the aging time of 10 minutes and the aging type set to inactivity. Port security violation modes. So if the MAC address of a device attached to a port differs from the list of secure addresses, then the port violation occurs and the port enters the error disable state. Remember that? The whole point of the port security to make sure that we secure that port, right? So how it's going to secure it is that if a MAC address of a device attached to a port differs from the list of secure addresses that it is supposed to have for that port, then that port will go into the error disable state. But you can set the security violation mode by using the following command, which is the switch port-security violation, and you can issue either shutdown, restrict, or protect. So depending on which option you pick here, the error disable state gonna be different based on whatever the option you have selected for the port security violation mode. So that's what we are doing here. So by using switch port-security violation, and then by issuing one of these options, by picking one of these options, either shutdown, restrict, or protect, we decide what's going to happen if the port is going into the error disable state. So the following table shows how a switch reacts based on the configured violation mode. And for your Cisco exams and quizzes for this class, you should know what each of these modes gonna do to your switch port security violation. So if during an exam or a quiz, both Cisco CCNA and CCNP, they could ask you if the switch port security violation is set to shutdown, what will happen? If the switch port security violation is set to restrict, what will happen? And so on and so forth. So you should know what each of these mode does and what would happen as a result of it. So let's look at that in a little bit detail. So in here we have the switch port mode shutdown, which is the default mode. So if you do not run the switch port-security violation and you don't pick one of these and you don't run this command at all, and you set the port security and all the other options, what's going to happen, the mode will be automatically set to shutdown mode. So what does it do? So the port transitions to the error disable state immediately, turns off the port LED and sends a syslog message. It increments the violation counter. When a secure port is in error disable state, an administrator must re-enable it by entering the shutdown and no shutdown commands. So by default in port security, it will be in shutdown as the violation mode. And if the violation occurs, it goes into the error disable mode, and an administrator has to manually re-enable by entering shutdown or no shutdown commands. So if you decided to go with the restrict option here, the port drops packets with unknown source addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value or increase the maximum value. This mode causes the security violation counter to increment and generates a syslog message. So in the restrict mode, what's going to happen if you connect another device with MAC addresses, the port drops packets with unknown MAC addresses or source addresses until you remove a sufficient number of secure MAC addresses to drop below the maximum value or increase the maximum value. So if you have a maximum value of 1 and you just connect a device, it will be fine. If you connect the next device, it's just going to drop it, because reason for that is now it is over that threshold, right? If you have a maximum value of 10, what's going to happen is if you have already a device connected, you can connect up to 10 devices. But after it reaches the 10 devices, it start dropping the packets and it's going to increment the security violation counter. That's what's going to happen in the restrict. The other option called protect. So this is the least secure of the port security modes. the port drops the packets with unknown MAC source address until you remove a sufficient number of secure MAC addresses to drop below the maximum value or increase the maximum value. However, in this protect mode, there will be no syslogs are sent and the counter won't be, increased as well. So there won't be violation counter increase either. So this is the least secure of the three options. Again, if you have a maximum number of MAC addresses that will be dynamically learned to 5, you can connect up to 5 until it start dropping. If it is set to 1, after you connect the second device, it will start dropping those packets. You should know what each of these modes are and how they are differ from each other, and you should be able to describe the differences between these options in most lab exams to your instructor. So depending on who is administering your lab exams for this class, whether through your academic institution or directly through Cisco, they will ask you these type of questions. Like they will ask you during lab exam, for example, for a verbal questions, if you have any verbal questions, or it could be like a written question. What would the switchboard port security violation restrict do? And how does that differ from protect or shutdown? So make sure not only you know how to describe them and understand them for your multiple choice quizzes and exams, but you should be able to also describe this to your instructor or the Cisco people if they ask you during a lab exam. So in this example, an administrator is changing the security violation to restrict. Remember, restrict, if you go to the previous slide, this is the option they are picking, the restrict option. And the output of the show port security interface command confirms that the change has been made. So how you do this is you go into the interface, so INTFA01, and then you're going to issue the command switch port dash security violation, and you're going to issue the restrict in here because that's the option they have chosen to give here. And then when you run the show port dash security interface F01, you see that the violation mode is now set to restrict, and you can see the other option that has been set here as well. Ports in error disable state. So when a port is in shutdown and placed in the error disable state, no traffic is sent or received on that port, right? So a series of port security related messages display on the console as shown in the example below. So note the port protocol and link status are changed to down and the port LED is turned off. So in this example, we have a situation where the port is in shutdown and in the error disable state, and the Cisco conveniently start displaying these related messages on the console showing that it is disabled and the port is in violation. Right here it says P secure dash violation error detected FA018, putting FA018 in error disable state. That's a very convenient, easy to read, human readable error message that is very useful, provided by Cisco. I love these messages, especially on lab exams. When I was working on lab exams, sometimes things go haywire, and sometimes these error messages are very useful. So I have used these error messages to correct my mistakes sometimes, and it will be very helpful to the network administrator. In the example, the show interface command identifies the port status as ERR disable. That means error disable. You can see that on here on the right hand side. The output of the show port security interface command now shows the port status as secure shutdown. You see that right here, the port status is showing as secure dash shutdown, and that's where the ERR dash disable. So the port is down and it is in secure shutdown. You know that because it's shown under the show port dash security interface, whatever the interface that you're looking at. So the security violation counter in here shows as 1, because the counter has been in counting how many times the error, this situation has occurred, and it has been counted once, so it incremented 1. The administrator should determine what caused the security violation. If an unauthorized device is connected to a secure port, the security threat is eliminated before re-enabling the port. So it is important that you need to, eliminate that security threat before re-enabling the port. To re-enable the port, first use the shutdown command, because you need to shut this thing down first, because this is in error disable state. To get out of the error disable, you're going to issue the shutdown command. Then use the no shutdown command to re-enable that port. So that's how you reset a port that would go into error disable state. So verify port security. After configuring port security on a switch, check each interface to verify that the port security is set correctly, and check to ensure that the static MAC address have been configured correctly. To display port security settings for a switch, use the show port-security command. So if you want to know the port security for that switch or whatever the switch you are working on, you go into the CLI and you're going to enter show, then space port-security command, and that will show you all the port security that is associated with each port on that switch. In this example, it indicates all 24 interfaces are configured with switch port-security command, because the maximum allowed is set to 1 and the violation mode is set to shutdown. No devices are connected, therefore the current address count or current ADDR is sitting at 0 for each interface. So you see right here, the current ADDR, current addresses attached to it, is set to 000, and you see all the ports here associated with this switch, and they all have the security enabled, and you can see that through by running the show port-security command. You can use the show port-security interface command to view details for a specific interface, such as shown in here on the right hand side. So in here, show port-security interface fast Ethernet 018 would display the FE018 interface information associated with it. So if you're a system administrator or a network administrator who just received access to a switch and you have no idea what ports are configured how, I would first run this command first, the show port-security command, which will display all the information that you need. And using that information, now you can run a command to look at specific security configuration for the specific ports. In this case, we are looking at the F018, and it shows the port security information and we know the port security is enabled right here, and we know the status of that port, and it is up and it is secure, and we know what violation mode is set to, which is set to shut down, and we have some other information such as the security violation counter associated with that port. To verify that MAC addresses are sticking to the configuration, use the show run command as shown in this example on the right hand side. So you can run the show run, and you can pipe that show run command with the only that interface that we are looking at. So we're going to use begin, and then we're going to use int fe019, or you can enter this complete command as shown here, and that would result in looking at those information that you're searching for. In this case, we are verifying that the MAC address are sticking. So we can see the port security MAC address sticky is there, and we have a sticky MAC address right here, right? If you don't use the pipe here, what's going to happen is all the information associated with the show run command will be displayed. And again, I will show you these examples on a lab demonstration on a later shorter video on my YouTube channel. To display all secure MAC address that are manually configured or dynamically learned on all switch interfaces, you can run the show port-security address command. And in this example, when that command was run, you see that the secure MAC address table is displayed, and you have the MAC address, associated VLANs, and the type. So we have one secure dynamic, the other one have secure sticky, and the port associated with that. So these are very useful information that as a system administrator or network administrator that you can use to identify any issues or look at how your configuration is set up. There is a packet tracer file called implement port security. It is available through your Cisco NetAcad as well as maybe through your academic institution. If you do not have access to this packet tracer file, I will find a copy and post to my website so you can go ahead and download and do them. I would recommend again doing these labs and packet tracer files as you go through these lectures so that you have a comprehensive understanding about what we are covering. Mitigate VLAN attacks. On our previous module, we learned about how VLAN attacks happen, and if you would like to know more extra detail than what we have on this slide, please go ahead and watch my previous lecture on my YouTube channel. So here is an overview of how the VLAN hopping attacks work. So there's three ways to do it. One is the spoofing DTP messages from the attacking host to cause the switch to enter trunking mode. From here, the attacker can send traffic tag with the target VLAN, and the switch then delivers the packets to the destination. The other way of doing this is to introduce a rogue switch and enabling trunking on that. Then the attacker can use that to access all the VLANs on the victim switch from that rogue switch. Another type of VLAN hopping attack is a double tagging or double encapsulation. In this method, the attacker takes the advantage of the way the hardware on most switches operate. Again, if you would like to know more details about these things, please go and watch my previous lecture. So what are the steps we can use to mitigate VLAN hopping attacks? You can use the following steps to mitigate VLAN hopping attacks on your Cisco switches. One of the first thing we can do is to disable DTP or auto trunking. So the disabling of DTP negotiation on non-trunking ports will mitigate the issue. So to do that, we're going to use the switch port mode access on the interface configuration. And what that will do is that will make sure that particular port will not have the DTP on there. So in here, for example, in the interfaces from FA01 all the way to 16, that range is put under switch port mode access. Hence, we have effectively disabled the DTP. The next one we can do is to disable unused ports and put them in an unused VLAN. So you can create a unused VLAN. In this case, they are using VLAN 1000. So by assigning all the unused ports associated with your switch into that the unused VLAN, we effectively put those ports in isolation. So you disable unused ports and put them into an unused VLAN, will isolate those switches from the rest of your network. Step 3, you can manually enable the trunk link on trunking port by using switch port mode trunk command. So if you use the switch port mode trunk command, which is shown here, right here, switch port mode trunk, you are basically manually enabling the trunk link on your switch. So in here, interface range from FA021 to 24, we have put it into trunk mode. Step 4, disable DTP, also known as the auto trunking, negotiations on trunking ports by using the switch port negotiate command. So not only you can put the switch port mode into trunk here on the same ports, we can enter the switch port negotiate, and what that's going to do is it's going to disable DTP, auto trunking negotiations, on those ports that we are working on. Finally, the step 5, what we can do is to set the native VLAN to a VLAN other than VLAN 1, because remember, VLAN 1 is the default VLAN for all Cisco switches and routers. So most attackers or threat actors would already know about that default VLAN. So what we're going to do is we can set the native VLAN to a VLAN other than that default VLAN, which is VLAN 1. You can do that by entering the switch port trunk native VLAN, and then you can give a random VLAN that is not in use, or you can set up a native VLAN that you should be using. In this case, actually, don't put it into a random VLAN. You should actually put it into a newly set up native VLAN. In this case, they are using the VLAN 999. So these are the 5 easy steps that you can take on Cisco devices that include switches and also routers to make sure that the interfaces are secured. So it is very easy, and in fact, I would pause this video on this screen and understand these commands and how they can be used and what they do for your exams and quizzes, and also you can use this in the field, because this is very easy 5 steps you can take to mitigate VLAN hopping attacks. Mitigate DHCP attacks. So let's look at the DHCP attacks. Here again, this is just an overview. So the goal of a DHCP starvation attack is to is basically to use an attack tool such as a Gobbler to create a DOS for connecting clients. So basically, it's a denial of service attacks. So basically, we learn, if you recall from our previous lecture, DHCP starvation attacks can be effectively mitigated by using port security, because Gobbler uses a unique source IP address for each DHCP request sent. Right? Remember that. The port security we learned in previous slides, as well as you can recall from how the DHCP attacks work from our previous lecture. You can pretty much use the port security as one of the method of mitigating this. However, mitigating DHCP snooping attacks require a little bit more protection. So Gobbler could be configured to use the actual interface of MAC address as the source Ethernet address, but specify a different Ethernet address in the DHCP payload. This would render port security ineffective because the source MAC address would be legitimate. So what can we do? Well, the DHCP snooping attacks can be mitigated by the DHCP snooping on trusted ports. Again, if you don't remember how DHCP attacks work, please go and watch my previous lecture video, and I will also leave a link in the description too, so that it's easy for you to find, and that will explain this in much more detail. But what you need to remember from our previous lecture is that the Gobbler is basically being used by threat actors for like the DHCP starvation attacks. And also the other method of you can attack a DHCP server is the DHCP spoofing attack. So those are the 2 attacks types, and we are trying to mitigate. And the DHCP starvation attack, which is a type of DOS attack, denial of service attack, can be mitigated using the port security, which we have covered in the beginning of this lecture. But for the DHCP spoofing attack, we need the DHCP spoofing on trusted ports enabled. So we will look at that on our next slide. So DHCP snooping. So the DHCP snooping filters DHCP messages and rate limits on DHCP traffic on untrusted ports. So devices under administrative control such as switches, routers, and servers are trusted sources, right? And then trusted interfaces, example trunk links and server port, must be explicitly configured as trusted. Devices outside the network and all access ports are generally treated as untrusted sources. So remember, trusted ports are ports that are facing, as I mentioned in the previously, things like servers, switches, routers, they are under our control, and we know that they are secure. So those could be they are considered as trusted port, and therefore those will have trusted interfaces such as trunk links. So we know we have full control, right? But however, any device that is outside the network and all access ports are generally treated as untrusted sources. So any devices that are probably, if you have an office where you have bring your own device, for example, that can be considered as a outside person accessing your network, those are generally treated as untrusted sources, right? And all access ports, basically, in other words, that people are using to connect their end devices, are considered as untrusted sources. A DHCP table is built that includes the source MAC address of a device on an untrusted port and the IP address assigned by the DHCP server to that device. The MAC address and the IP address are bound together. Remember those MAC address tables and CAM tables? So yeah, that's what happens. So therefore, this table is called the DHCP snooping binding table. So the MAC address and the IP address are bound together using this DHCP snooping methodology and the filtering system, and therefore this table is called a DHCP snooping binding table, which is very similar to MAC address tables and CAM tables that we went over in our previous lectures. So what are the steps that you can take to implement DHCP snooping on a Cisco device? So on a Cisco switch, you can follow these 4 steps to implement DHCP snooping. First is to enable DHCP snooping by using the IP DHCP snooping command in the global configuration. So you're going to run IP DHCP snooping. That's the command. Next, on trusted ports, we're going to use the IP DHCP snooping trust in the interface configuration command. In other words, like you're going to go into the interface, for example, INTFE01, enter, and that will get you into the interface configuration command. And under the interface configuration commands settings, we're going to enter IP DHCP snooping trust, and then we're going to press enter, and that will get that command entered into that port, those trusted port. You can do it on multiple ports in one go as well, using the port ranges as well. So that's the second step you need to take. The third step is on untrusted interfaces, we're going to limit the number of DHCP discovery messages that can be received using the IP DHCP snooping limit rate. And then you're going to enter packets per second, like how many packets per second that the DHCP discovery will be received, like discovery packets will be received under that interface. So to do that, this is the command we're going to use. So IP DHCP snooping limit rate, and then you're going to enter the packets per second that port will be receiving for DHCP discovery messages. Step 4, we're going to enable DHCP snooping by VLAN or by a range of VLANs by using the IP DHCP snooping, and you're going to enter the VLAN, whatever the VLANs or range of VLANs in the global configuration command. So basically those are the 4 steps you need to take to implement the DHCP snooping on your Cisco switches. So here is an example of DHCP snooping configuration. And if you refer to the DHCP snooping sample topology with the trusted and untrusted port listed, you can see the untrusted ports are marked in red and the trusted port is marked in this purple color. So this trusted port is F01 and untrusted port is F05 facing the end device, and the trusted port is facing the DHCP server on this side. So the DHCP snooping is first enabled on S1. So you're going to run IP DHCP snooping. That's the command. The upstream interface to the DHCP server is explicitly trusted because we know that is a device under our control and connected to our side of the switch, right? So we're going to have interface F01. So we're going to go into the interface configuration mode, and then we're going to enter IP DHCP snooping trust. So that is now trusted. And we're going to exit out of that interface now. Then F05 to F024 are untrusted and are therefore rate limited to 6 packets per second. So we're going to go to interface range F05-24. Remember, that's how you enter a range of interfaces. And we're going to enter the command IP DHCP snooping limit rate, and we're going to put 6 because we're going to limit those ports to 6 packets per second. And we're going to exit out of that. Finally, the DHCP snooping is enabled on VLANs 5, 10, 50, 51, and 52. So how we have done this here is running IP DHCP snooping VLAN, and then you're going to enter the VLAN 5, 10. And from 50 to 52, we can enter as a range right here. So this is an example of range and Pacific VLAN entering example. And by doing that, we basically have created the DHCP snooping in this example. So now we have configured the DHCP snooping. The next thing we're going to look at is how we can verify this configuration. So for verification, you can run the show IP DHCP snooping command in the privilege executive mode. And when you enter that command, you will get the information related to DHCP snooping, and it will have the information showing here saying it is configured with what interfaces associated with that. Then you can also use the show IP DHCP snooping binding command. This command will let you view the clients that have received the DHCP information with that snooping configuration. In here, in this example on the right hand side, we see the show IP DHCP snooping binding being issued here, and the table shows a device that been connected with IP address 192.168.10.10 with the DHCP snooping configuration attached to it. Please note the DHCP snooping is also required by Dynamic ARP Inspection or DAI, which we will cover in the next few slides. Mitigate ARP attacks. Dynamic ARP Inspection or DAI. In a typical ARP attack, a threat actor can send unsolicited ARP replies to other hosts on the subnet with the MAC address of the threat actor and the IP address of the default gateway. So to prevent ARP spoofing and the resulting ARP poisoning, a switch must ensure that only valid ARP requests and replies are relayed. The Dynamic ARP Inspection or DAI, along with the DHCP snooping, what it's gonna do is it will not relay invalid or wrong ARP replies out to the other ports in the same VLAN. It will intercept all ARP requests and replies on untrusted ports. It will verify each inspected packet for a valid IP to MAC binding, and it can drop and log ARP requests coming from invalid sections to prevent ARP poisoning. And finally, it can also error disable the interfaces if the configured DAI number of the ARP packet is exceeded. So how do you implement DAI? So here is a guideline that you can use for implementing DAI. So to mitigate the chances of ARP spoofing and ARP poisoning, you can enable the DHCP snooping globally. You can enable the DHCP snooping on selected VLANs. You can enable DAI on selected VLANs. And you can configure the trusted interfaces for DHCP snooping and ARP inspection. It is generally advisable to configure all access switch ports as untrusted and to configure all uplink ports that are connected to other switches as trusted. So in other words, if you have a switch that is outward facing, where you have your end devices, the clients that get access to, so all of these access ports can be configured as untrusted ports because they are outward facing. But any ports that are between switches and routers and other intermediary devices, those can be configured as trusted ports. And please remember this topology, because in the next slide we will be discussing that a little bit. So in the previous topology, the S1 is connected to 2 users on VLAN 10. So if you go back into the topology, if you just don't remember, we have the VLAN 10 and we have 2 users. One is a real user, the other one is a threat actor, right? DAI will be configured to mitigate against ARP spoofing and ARP poisoning attacks. DHCP snooping is enabled because DAI requires the DHCP snooping binding table to operate. Next, the DHCP snooping and ARP inspections are enabled for the PCs on the VLAN 10. The uplink port to the router is trusted and therefore is configured as trusted for DHCP snooping and ARP inspection. So on the right hand side, you see the configuration that they are doing for the switch 1, which is the switch right here. This is the switch 1, right? So in here we have IP DHCP snooping command, IP DHCP snooping VLAN 10, and IP ARP inspection on VLAN 10. And then the interface FA024, we have IP DHCP snooping trust and IP ARP inspection trust. Because FA0/24, if you look at the diagram here, is facing towards an internal device, intermediary internal device. So it is a link between the switch 1 and R1, and we can trust that port. But you cannot trust the FA0 and FA02. So we're going to run the snooping commands here, but we will issue the trust commands into the interface FA024, which is connecting to the router. DAI can also be configured to check for both destination or source MAC and IP addresses. Destination MAC, that will check the destination MAC address in the Ethernet header against the target MAC address in ARP body. Source MAC checks the source MAC address in the Ethernet header against the sender MAC address in the ARP body. IP address, which checks the ARP body for valid and unexpected IP addresses, including the addresses 0000 and also 255.255.255.255 and all IP multicast addresses. So this is how this DAI will check such information. The IP ARP inspection validate command with these options in the global configuration mode can be used to configure DAI to drop ARP packets when the IP addresses are invalid. It can be used when the MAC addresses in the body of the ARP packets do not match the addresses that are specified in the Ethernet header. And notice in the following example how only one command can be configured. Therefore, entering multiple IP ARP inspection validate commands overwrites the previous command. To include more than one validation method, enter them on the same command line as shown in the output. So if you look at on the right hand side, you see IP ARP inspection validate SRC-MAC, and on bottom here it shows IP ARP validate SRC-MAC DST-MAC IP. So if you want to enter the SRC-MAC and DST and IP, if you want to enter all of these three, You cannot enter one at a time, because what's going to happen if you look at your configuration by running do show run, you will see only the last command that you have entered is now in the system. So if you want all of these three items, if you want to have IP ARP inspection validate done on both Mac, the source Mac, destination Mac, and the IP address, what you need to do, actually, you need to enter it as a one single command. So IP ARP inspection validate src-mac, dst-mac, and IP. So it will give you a source Mac, destination Mac, and IP. And if you run show run in here, do show run, and it will end up showing that it is now a valid command that's currently running. So keep in mind that. So entering multiple IP ARP inspection validate commands will override the previous command. Therefore, you need to enter all of these options if you're going to use all of these options in one single command. Mitigate STP attacks. Portfast and BPDU guard. Recall that network attackers can manipulate the spanning tree protocol, also known as STP, to conduct an attack by spoofing the root bridge and changing the topology of a network. And again, I discussed this in detail in my previous lectures, and if you don't remember, you're more than welcome to go ahead and check that on my YouTube channel. To mitigate STP attacks, use Portfast and Bridge Protocol Data Unit BPDU guard. Portfast, basically what it does is it immediately brings a port to the forwarding state from a blocking state by bypassing the listening and learning states. Apply to all end user access ports. So you can add the Portfast command to all the access ports on your switch. BPDU guard is a option that you can use to immediately error disable a port that receive a BPDU frame. So if that port receive a BPDU frame, it will immediately put it into the error disable state, that port. Just like Portfast, BPDU guard should only be configured on interfaces attached to the end devices, because end devices does not need the BPDU transmission, right? So that's why. Configure Portfast. Portfast bypasses the STP listening and learning states to minimize the time that access ports must wait for STP to converge. So only enable Portfast on access ports, as I mentioned before. Portfast on inter-switch links can create a spanning tree loop, so make sure you don't do that on your intermediary links. Portfast can be enabled on an interface, or you can enable globally. If you are enabling on an interface, use the spanning-tree Portfast under the interface configuration command. Globally, you can use the spanning tree Portfast default under global configuration to enable Portfast on all access ports. So on the right hand side, it is showing the interface FA01 is sent to switch port mode access. Spanning tree is set to Portfast, hence it's enabling Portfast. And Cisco iOS conveniently giving you warnings that Portfast should only be enabled on ports connected to a single host, and all that that information is being displayed. And if you want to do globally, that would be the spanning tree Portfast default. So that's what is showing on the right hand side. To verify whether Portfast is enabled globally, you can use either the show running -config with piping with the begin with span, and that will show you that information, or you can run show spanning-tree summary command. To verify if Portfast is enabled in an interface, use the show running-config interface with the interface number. For example, FA01, for example, it will be show running-config interface FA01, for example. The show spanning tree interface with the interface number and detail command can also be used for verification. So in that case, spanning -tree interface, then you're going to go FA01 for example, and then detail and press enter, and that will also give you some information about the port fast configuration. Configure BPDU guard. An access port could receive an unexpected BPDUs accidentally or because a user connected to an unauthorized switch to the access port. If a BPDU is received on a BPDU guard enable access port, the port is put into error disable state. Remember, if it goes into error disable state with the BPDU guard, that means that BPDU frames and packets will not get switched into the network. This means the port is shut down and must be manually re-enabled or automatically recovered through error disable recovery cause violation global command. BPDU guard can be enabled on an interface or globally. So on an interface, we use the spanning -tree BPDU guard enable inside the interface configuration. Globally, we can use the spanning -tree port fast BPDU guard default inside the global configuration mode. So on the right hand side, we have a switch S1, and we have inside the interface, you go into the interface configuration, in this case is FA01, and we are issuing spanning -tree BPDU guard enable, and if you exit out of that, you can see that it is now configured in the interface, right? But by running spanning tree port fast BPDU guard default, what's going to happen is it will be enabling on all ports. And then you can use the show spanning -tree summary to see what configurations are enabled, and that's the summary showing on here. Again, this particular lecture is very theory and lab heavy. So I would say it's very lab heavy actually. So I know I went through a lot of information, a lot of theory information, but also a lot of lab information. So I will post some videos related to these commands in real lab demonstration and post to my YouTube channel later. For now, just remember these commands exist and where we can use these commands. That would bring us to the end of this lecture, and I will go over what we have covered. There is a packet tracer file called switch security configuration. If you have access to this file through Cisco NetAcad or through your academic institution, please go ahead and do them. If you do not, I will try to find a copy of that and post to my sanuja.com website. And this is a really good packet tracer file that will cover everything that we have just covered. There is also a lab called switch security configuration. Again, if you have access to this file, go ahead and do them. If not, I will post a copy of this lab to my sanuja.com website, so you can go ahead and do them. And let's look at what we have learned in this lecture. We learned all switch ports, in other words interfaces, should be secured before the switch is deployed for production use. By default, layer 2 switch ports are set to dynamic auto, in other words trunking on. The simplest and most effective method to prevent MAC address table overflow attack is to enable port security. And we learn how we can do that. The switch can be configured to learn about MAC addresses on a secure port in one of the 3 ways: manually configured, dynamically learn, and dynamically learn sticky. We also learn if the MAC address of a device attached to the port differs from the list of secure addresses, then the port violation occurs. By default, the port enters the error disable state. When a port is placed in the error disable state, no traffic is sent or received on that port. Mitigate VLAN hopping attacks by disabling DTP negotiations, disabling unused ports manually setting trunking where required, and using a native VLAN other than VLAN 1. So that's how you can mitigate VLAN hopping attacks. We also learned the goal of a DHCP starvation attack is to create a DOS for connecting clients. DHCP snooping attacks can be mitigated by using DHCP snooping on trusted ports. We also learned DHCP snooping determines whether DHCP messages are from an administratively configured trusted or untrusted source. It then filters DHCP messages and rate limit DHCP traffic from untrusted sources. We learn about dynamic ARP inspection, also known as DAI, which require DHCP snooping and help prevent ARP attacks by verifying the ARP traffic. We learn how we can implement dynamic ARP inspection to mitigate ARP spoofing and ARP poisoning. To mitigate spanning tree protocol STP manipulation attacks, we learned that we can use portfast and bridge protocol data unit BPDU guard. So to mitigate STP manipulation attack, we use the portfast and the BPDU guard. And that is the end of this lecture. If you like these type of lectures, please thumbs up this video and subscribe to my channel. If you have any questions or concern regarding any of the items that we have covered today, please don't hesitate to reach out to me. You can either leave a comment in one of my videos or you can reach out to me through my website. Please go over all the notes before you do your exams or quizzes, and good luck with your exams and have a nice day.